We want to find log base 5 of 49 over 5. So if we are doing this completely with our calculator, I know, absolutely, you can go to your calculator, you can do change of base, and you can get the number here. But what this is testing is, do you understand the properties of logarithms? So we are limited to using the numbers 6, 8, and 7, and we could also use the base as well. So 5, 6, 7, and 8 are the only numbers that we can use. So anything within our problem, we need to relate to those numbers. So the first thing that I see is that 49 can be written as 7 squared. 49 can be written as 7 squared. So we want to go ahead and rewrite that. 49 is 7 squared. So that's good, because now it's in terms of what are the numbers that have information about. 5 is my base, so I can use that. This time we're actually going to expand this. Since we're dividing, then our property says that that is the difference of 2 logs. And we're going to go backwards with our power property, and we're going to move that exponent to become a coefficient. Now, log base 5 of 7, they gave me that. It's 1.2. So I've got 2 times 1.2, because they told me what it was equal to. Log base 5 of 7 is equal to 1.2, so I'm going to replace it. Now, log base 5 of 5, they didn't give it to me, but let's think about what a logarithm means. It means that your base raised to some power is equal to what's inside of the logarithm. So 5 raised to some power is equal to 5. So what's that power? 1. Log base 5 of 5 is equal to 1. So we've got 2 times 1.2, that's 2.4. 2.4 minus 1 is 3.4. Now, I would want you to confirm that with your calculator. Log of 49 over 5 divided by the log of 5. Wait, what did I do? I added? Yeah, that's smart. I added. Subtract 2.4 minus 1 is 1.4, not 3.4, and that's why you always check your answer. Why you always check your answer. Because sometimes you do dumb stuff. Even I do dumb stuff sometimes. Okay, let's look at this example. Log base 3 of 7 is equal to A. We don't have a value. They give us a variable for that number. Log base 3 of 10 is equal to B. Log base 3 of 8 is equal to C. We want to find log base 3 of 8 over 27. So in this case, you have to know how these properties work, because your answer is going to be in terms of variables. It's not going to be an actual number. Now, you can still check it, and I'll show you how that'll work here in a second, but you have to know how these properties work to be able to express this answer correctly. So again, the numbers that we're allowed to use, 3, 7, 8, and 10. 3, 7, 8, and 10 are the numbers that we are allowed to relate to here. So when I look at what they're wanting me to evaluate, 8, I'm good. That's one of my numbers. So I don't have to do anything there. 27 is not one of those numbers. I have to relate it to one of those numbers using powers. So 7, 8, 10, not going to happen. It must relate to my base of 3. So 8 we can leave. 27 is 3 to the third. We are dividing again, so that is our quotient property. That becomes the difference of these logarithms. And then we have a power, so we want to move that in front. Okay, log base 3 of 8 is c, so we're going to replace that with the variable c. Log base 3 of 3, well, that's the problem we just looked at. We just did it with 5 instead. Log base 3 of 3 is equal to 1, so we have 3 times 1, which is, of course, 3. So this boils down to c minus 3. Make sure I didn't do anything stupid this time. I think we're good. Now, if you're going to check this one, it takes a little bit more work. You've got to plug in your log, divide by the log of the base. Okay, so that is the actual numerical value. Our answer said it was c minus 3, so we got to figure out what c is. That's the log of 8 divided by the log of 3. And then if we subtract 3 from that, we should get negative 1.107, and we do. Okay, so you can still check it. It just takes a little bit more work. Okay, let's do one more like that. One more like that, and we'll be good to go. Log base 4 of 9 is equal to A. Log base 4 of 5 is equal to B. Log base 4 of 6 is equal to C. And we need to find log base 4 of 1 over 120. 1 over 120. So we can use the numbers 4, 9, 5, and 6. We really don't have to worry about the 1, and I'll explain why here in a minute. So I'm just going to leave the 1 there. 120, though, we need to manipulate a little bit. Now, 120 is not a power of 9, it's not a power of 5, it's not a power of 6, it's not a power of 4. So if it's not a power, let's think about some of our other rules that we could use. We could use a product of two numbers. So 5 and 6 obviously multiply to give us 30. We could do multiple products. How about 4 times 5 times 6? 4 times 5 times 6 is 120. Now we have a quotient, so that becomes the difference. And then we're multiplying 3 things, so that becomes the sum there. Now, because we have this minus in front, we need to put some parentheses before what follows. So we can apply the product rule to more than 2 things. You can do it with 3 or 4 or more. It's usually, though, just 2 or 3. Okay, any questions about what I've done with this one so far? Okay, so let's do a little number crunching. Log base 4 of 1. 4 to what power is equal to 1? 0. Very good. 4 to the 0 is 1. Anything to the 0 is 1. So if you're taking the log of 1, it's 0. Log base 4 of 4 is 1. Log base 4 of 5 was B. Log base 4 of 6 was C. Now, if we're going to properly express that, that negative there gets applied to everything that follows. So the correct answer here is -1 minus B minus C.